that shows up on the podcast. So we're naming ionic compounds now. So you heard me when we did all the examples on the board. I'm actually giving a name. So you guys are going to learn to name them. So the first thing that we need to know is that what we are doing today is we are doing binary compounds. So we are doing compounds that have 2 atoms in them. So the first thing when you're naming them, these compounds start with a metal and end with a non-metal. Okay, so our first element is going to be the metal. Second element is the non-metal. That is an ionic bond. Binary ionic compounds always have 2 types of atoms. So typically we have the positive metal, the negative non-metal. When naming the ionic compound, you should name the cation first. So remember cation with the T in it, it's a positive ion. So the ion has the positive charge. Then the anion. Okay, so there is a specific order that you have to name them in. The ending of the first element does not change. So, for example, number 4 on the back board is Al2O3. Okay, when naming this compound, the first element, I'm still going to say aluminum. Okay, I'm not going to change how that is said. However, the second element, the nonmetal, always ends in IDE. So instead of saying aluminum oxygen, it is aluminum oxide. So I take that ending off and I put IDE. Binary ionic compounds are always neutral. So if I'm balancing these charges out, they have to equal 0. Okay? All right, so some examples. MgCl2. What does Mg stand for?
Magnesium.
Magnesium. Okay, so we don't change how it's spelled. So just as it is on the periodic table, we keep it just like that. Magnesium. Okay, Cl stands for chlorine, but since it's the second element, we say chloride. So we change that "ine" to an "ide" at the end. And that's it. So pretty simple in the naming process. Letter B. Ba, what's it stand for?
Barium.
Barium. So we keep it the same. O stands for
Oxygen.
oxygen. It's the second element, so I say oxide. Oxide. All right, try C and D. So again, remember the first element, we keep the name. The second element, we're going to change the ending to an IDE. And this is strictly ionic bonds. We're going to do covalent bonds later on. All right, what's Na stand for?
Sodium.
Sodium. P?
Phosphorus.
Phosphorus, since it's second.
Phosphide.
Phosphide. Very good.
Phosphide.
Okay, Al stands for
Aluminum.
aluminum. Aluminum. And then sulfur is sulfide. Remember IDE. IDE. Single elements end in IDE. I heard somebody say 8. Sulfate. Okay. So sulfate is actually on our polyatomic ion list. So remember I showed you this list. I also put it on Google Classroom. We can find sulfate on here. And sulfate is right there. There is a difference between just having sulfur in a compound and having a mixture of sulfur and oxygen. Okay, so you need to make sure that when it's just the element sulfur that it's S, and when it's sulfate, you have that SO4.
Is sulfate another kind of salt?
All right, so now just the opposite. Now we have the name, we're going to write the formula. So when we have to write the formula to this, we can't just say, okay, the first element's lithium, the second element's nitrogen, done. You actually have to balance the charges like we've been doing. So lithium has a what charge?
3 or 1.
How do we know that? How do we know the charge?
Because it's in group 1.
It's in group 1. So group 1 has positive 1 charge. Nitride, what element is that? Nitrogen. And the charge for nitrogen is -3. How do I know that? It's in group 5A, which has a -3 charge. Okay, so we need to balance the charges. So we either use the crisscross method, I don't know which you think's easiest. I'm going to add some more lithiums, 2 more, to get a +3 to balance out my -3. So I show that I have 3 lithiums with my subscript 3, and then a nitrogen. Okay. All right, barium oxide. Barium is Ba. What's the charge on barium? +2. How do we know that? It's in group 2A. The group 2A column has a +2 charge. Oxide represents oxygen. Oxygen has a -2 charge. Charges are balanced. Okay. All right. Try C and D. All right, magnesium. Mg has a charge of +2. It's found in group 2A. We're adding that to chloride, which is chlorine. Chlorine has a -1 charge. And so we balance those charges out. Right. We do the crisscross method. MgCl2. Okay. Aluminum bromide. Aluminum is Al, has a +3. Bromine has a -1. Yep. Crisscross our charges. AlBr3. Awesome. Okay, so those are the easy ones. Those are the binary ionic compounds with elements chosen not in the transition metal section. Okay, so I keep avoiding that transition metal section for a reason. It's a little bit more challenging than what the numbers that we've been doing. We're just doing 1 through 18. So, type 2 compounds. They're still going to be ionic compounds. This time we're going to use the transition metals. When we use the transition metals, when we are naming them, we have to use a Roman numeral. We look, my periodic table up here, and your periodic table doesn't have oxidation numbers. Some of these elements have multiple oxidation states. So for example, the atomic number 74W, that stands for tungsten, that has +6, +5, +4, +3, +2. Okay, if I move across, a lot of these have multiple oxidation states. So we have to identify which one of this atom we are talking about. Okay, so by doing that, we're going to use a Roman numeral. So do you guys remember the Roman numerals?
Yes.
All right, what's the Roman numeral for 1?
It's just an I.
I. What's the Roman numeral for 2?
It's like 2 I's.
I.
3 I's.
I.
4 I's. Oh,
B.
IV.
5
B.
is B.
And then
6.
VI.
Yeah.
And
We
then
will never go above that, but yeah, VII.
And then
IX. Right. Okay, so there are some metals that are not in this section that need a Roman numeral. So I want you to mark those. The atom number 50, which is tin, I want you to circle it. I put an R on top of mine just to make a note that it needs a Roman numeral. So this is tin, and then lead also needs a Roman numeral. Okay. Then there's a couple that are in the transition metal section that don't need a Roman numeral. They are always found at this state. So zinc element 30. This always has a +2 charge. So if you want to put a +2 on that box, that's going to benefit you. Does not need a Roman numeral. Cadmium, +2. And then silver is always +1. And again, I have them marked up here. So I'm pretty sure that everything I have marked, you should have marked as well, and there should be nothing else on there except for what I've told you to mark. So again, we are marking these because the transition metals need Roman numerals when we are naming them. The charge of the Roman numeral will help us when we're writing the formula. So for example, if I have tin 4 oxide, that means I'm using tin with a +4 charge. Okay, so that Roman numeral tells us the charge. We still name the cation first, so I'm still naming the metal and then the non-metal. All right? Let's do these. Okay, so copper. We find copper on the periodic table. Copper is a transition metal. It's in that middle section. I need a Roman numeral. So for now, I'm just going to put in parentheses a blank spot until we can figure out what that Roman numeral is. Second element is oxygen. When it's listed second, it's oxide. All right, so the Roman numeral part. The Roman numeral tells the charge. Well, what is the charge on oxygen? Try again. Try again. -2. Oxygen is found in 6A, has a charge of -2. So since oxygen's charge is -2, copper's has to be, what is, to balance it out, what? +2. If oxygen is -2, copper has to be +2 because they both have to be neutral. So we have the Roman numeral 2 in parentheses. All right, letter B, Mn. Mn is manganese, not magnesium, manganese. Okay, manganese has atomic number 25, so it is found in that middle section. I need a Roman numeral. And then Br is bromine, since it's listed second, bromide. Okay, let's find bromine on the periodic table. Okay, bromine is right here. It has a charge of -1. However, there's 2 of them, right? So that means that bromine's total charge is -2, yeah? So what does manganese charge have to be? +2. So what Roman numeral do we put in here? +2. It's not negative. It's a positive charge. I said bromine's charge is -2. Okay, manganese is +2. You will never have a Roman numeral with a non-metal. Only with the transition metals, and all their charges are positive. Okay? All right, try C on your own. See if you can figure out C. What's that? Yes. I've been pointing my periodic table the whole time. Yes, you need a periodic table. Yep. Selective.
A little bit, yes.
I have that.
Selective brightness.
Well, I'm pretty dark, so
Oh my gosh. I'm sorry for those of you that are listening to the podcast right now. Hearing all of this.
We're in a podcast.
Yeah.
Yeah, it's a podcast.
She goes to the beginning class.
I know.
All right, so Fe, what's it stand for?
Iron.
Iron, is it a transition metal?
Yeah.
Yeah. It is found in that middle section. What's Cl stand for?
Chlorine, but it changes into chloride.
Change it to chloride. Okay. So what is the charge on chlorine?
-1.
And of all the classes I chose to podcast, I did this one. I don't know why. So chlorine is -1. There's 3 of them, so that's a total of -3. So iron has to be +3. So the Roman numeral I write in here is
I.
3.
Yes, for the Roman numeral, not the number, so I just said.
All right, try letter D. Try letter D. in the year 2018, right?
No.
So like 5 years down the road, somebody's listening to this podcast.
That's weird.
They're gonna be like, oh, who's that?
Yeah. You throw them out. It's kind of annoying.
Why do you have
Really
to add your
annoying. You
race?
throw them out.
If I heard this podcast, I'd turn it off. Like
Yeah.
right when that joke just done. You know?
You'll miss all the answers.
I just never left it in half. You know?
Just turn the volume off. So you don't have to listen to it.
Just wait. Light spike.
All right, PB stands for lead. What is the charge on lead? Do we know?
No.
Not yet. We don't know yet. Okay, is it a transition metal? Is it one that needs a Roman numeral?
Yes.
Yes. Okay, S stands for
Sulfur.
sulfur sulfide. Yep. Okay, so sulfur has a -2 charge. There's 2 of them, so that makes a total -4. So lead has to be a +4 to balance out the charge. And so IV is the Roman numeral for 4.
Funny thing is, less in the column of +4/-4.
And no, it's not.
It's
It's the one that I told you to circle.
Oh, I did circle it.
Remember I told you circle because that means a Roman numeral. Okay, so next. Nickel. Ni is nickel. Nickel is a transition metal, needs a parenthesis. N is nitrogen. We say nitride. Again, make sure it's IDE at the end. Okay, so nitrogen, we find nitrogen on the periodic table. It's in group 5A, atomic number 7, has a charge of -3, but I have 2 of them. So that's a charge total of -6. So nickel's total charge has to be +6. However,
There's 3 of them.
there's 3 of them. So what is each nickel's charge?
2.
2. We take 6 divided by 3. Each of them have to be 2. So in this Roman numeral, it is the charge of 1. This whole time, A through D, there's only been 1 metal. Okay, there hasn't been a subscript that we had to worry about. But we have to make sure we know that charge is for the single element, not for the whole thing. So we should not have a 6 inside that parenthesis. Okay? So this is the more challenging part. The easier part now is to go to the balancing because now the Roman numeral tells us the charge and we don't have to look it up. So, letter A. Manganese is Mn with a +2 charge. Iodine is I with a -1 charge. We balance our charges. Yep. Crisscross. Applesauce. So you need 2 iodines. Alright, letter B, iron. Is Fe, has a +3 charge. I'm adding that to nitrogen. Nitrogen has a -3 charge.
It works.
Charges are balanced. Alright, you notice that in the formula we don't have Roman numerals. Okay, you only use Roman numerals for the name only. Alright, try letter C.
Like, uh,
Try letter C.
Cobalt.
It's cobalt.
Oh, okay.
Oh.
No.
Alright, cobalt. CO has a +2 charge. Chloride is chlorine, and chlorine has a -1 charge. I need another chlorine, so I need to show in my formula that I have 2 of them. Yep. Alright, letter D, tin. Tin is SN. Roman numeral 2 tells us it has a +2 charge. Don't confuse the Roman numeral with the number of that atom. That happens every year. Roman numeral tells us the charge, not how many there are. Okay, so SN2, sulfur is S with a -2 charge. Charges are already balanced. Letter E, copper. What's the symbol for copper? See you later. +1 charge. We have a 1 Roman numeral. Phosphide is phosphorus, which has a -3 charge. Crisscross, we need 3 coppers. And 1 phosphorus. Yep. Okay, so this isn't so bad. It's remembering that the elements need Roman numerals is where it gets you. Okay? Alright, let's take a look at the homework. Yep, there's homework tonight.
Wait, what?
Alright, so that full sheet that you guys picked up, that is your homework. So we're going to take a look at this because there's a little bit of confusion with some people. So, alright, I'm only going to be assigning 1 through 6. Okay, so circle 1 through 6, those are the only ones that you have to do.
The best. If you go to pocket third
Okay, so we're going across each row with the information that they gave us. Okay, so looking at the first one, ion formula, it tells us Hg. So in the first column, we need to put what is the name of that element. Then we go along further. Ion formula, Cl. What is the name of that element that is listed?
Chloride.
And then compound name.
Oh.
So now you're going to name it. You have Hg and Cl. How do I name that compound? Remember, Roman numerals. Do not forget, when you find the element on the periodic table, like what Hg represents, what does this element need when we name it? It needs a Roman numeral. Okay, so do not forget the Roman numeral when you have the name of it. And then we put the chemical formula in the last column. Now, all of these compounds that we've been doing, what do they end with? IDE. IDE. Okay, so let's look at this. Number 2, does it end in IDE?
No.
No, it doesn't. Red flag.
Wow.
Okay? That means that it is not an element found on the periodic table. So we have to go to the polyatomic ion list. And the name was carbonate, right?
Yeah, sodium carbonate.
Okay, so we have carbonate.
There it is, CO3.
CO3 with a -2 charge. Okay, so on this document, ion name, it's the second ion, so let's write carbonate. And the formula, the ion formula, is CO3. And what was the charge?
-2.
Yep. Okay. All right, then I look down a little bit further. Look at number 3, sulfate. So what's that mean?
Sulfur.
It's not wrong. Nope, it's not sulfur. Does it end in IDE?
It's not on the periodic table.
Right, it's not sulfur. It means that it's on the polyatomic ion list. So I go back to that list, and I find sulfate right here. Sulfate is SO4 with a -2 charge. So in this column, SO4 with a -2 charge. Okay, so again, all of these compounds that we've been doing has only 2 elements. Let's look at this example here. This is number 4, CrPO4. Red flag. Okay, that second element there, PO4, that second compound, that's not on the periodic table by itself. So I go to my list.
It's got to do something with sulfur and oxygen.
PO4 is phosphorus and oxygen. PO4 has a -3, it's called phosphate. So that second element, the PO4, is called phosphate. And has a -3 charge. And last one, and this one's kind of tricky, it does end in IDE. Remember I said that there's 2 on the list, cyanide and hydroxide, that are on the list that are not just hydrogen. So hydroxide is actually OH with a -1 charge. Okay?
So it's OH with -1 charge.
Yep. So you need to go in and finish these rows 1 through 6. Compound name, chemical formula, okay, for tomorrow.
So they all have a chemical formula.
Yeah, absolutely. They all have a chemical formula.